Matplotlib is a library of graphics functions. We will use its module pyplot, which provides the functionality of MATLAB plotting. Import it with from matplotlib import pyplot as plt, or import matplotlib.pyplot as plt. We will need NumPy, so let's import it. Start with a list and plot a graph using plt.plot. This plots y versus a default array of index values. It has been plotted by default in the Spyder plots console. This is called inline mode because a previous version of Spyder plotted the graph in between lines in the IPython console. Now let's plot y squared. This doesn't work because arithmetic can't be done with the list type. Plot accepts a list but works internally with NumPy arrays, so let's do the same and create an X array. As a NumPy array, X can be squared. Let's plot this and this. Inline plotting is useful for a single plot, and successive plots are stored for browsing and can be easily copied, saved and cleared, and all plots can be cleared with one click. But this does not allow for overplotting for multiple plots on the same set of axes, or even for adding labels, so we will use a separate window by typing the magic command in IPython %matplotlib qt5. To return to inline mode, type %matplotlib inline. Let's start again with an X array of 51 points over the domain 1 to 9, and create a Y array that is a function of X. Then plot Y versus X with 2 arguments to plot. Fit the view to the data with auto scale and tight set to true. The limits of the plot can be set with the xlim and ylim functions. This can be done with one function called axis, with a list as an argument, with xmin, xmax, ymin, and ymax. To plot the axis lines, which is what we normally call the axes, use the axh line and axv line functions set at the selected vertical and horizontal points respectively with an optional color. Add a grid if you wish, and axis labels, and a title with an optional font size. Now let's clear the graph with the clearAxes CLA function. This clears what is drawn on the graph area but leaves the axes. To clear the figure completely, use the function clf. A figure is a drawing region that can have one or more panels called axes. A new figure is created automatically as figure 1 when a plot is done, but a blank figure can be created with the statement plt.figure. And add axes with plt.axes. Note that the toolbar enables the figure to be saved and other actions. A figure can also be saved with plt.savefig with the file name. The file is saved as a PNG file in the current working directory, which can be shown in IPython by the magic command pwd, which stands for print working directory, and the PNG files listed by ls for list star.png. Additional figures can be created by calling plt.figure again, which numbers the figures 1, 2, 3, and so on, and a number can be assigned as an argument. Once the figures exist, a figure can be selected with its number, which becomes the current figure, so the next plot will be on this figure. Several plots or axes may be shown on one figure with the subplot function. This has arguments nx and ny for a rectangular grid of panels or axes, and n selects the current axes counting left to right from top to bottom. To delete the current axes, use del axes. Let's start with a new figure. Use plot with data equals none to plot just the axes. We plot the graph again, but with the selected color, line width, and line style. Let's plot the line again with different choices using abbreviated notation. Note that the keyword color is not needed, but B is simply in quotes. There is even shorter notation for the line style grouped with the color black, where black is represented by the symbol K. Now plot the graph with markers added to the line. Change color of line and markers to red, or use options to change the marker size and fill color. Which can be abbreviated as follows. The markers can be plotted without the line using the empty line style, or as a separate plot, which can be abbreviated. We can also add a label to the line and add a legend to the plot. This is useful for distinguishing between different plots on the same axes. Let's plot the trajectory of a projectile. The X and Y scales we see are different. To plot it as it actually would look with equal X and Y scales, use the following. This can be set back to independent scaling. GCA means Get Current Axes. A simple animation can be produced by successively clearing the axes and plotting an updated graph and pausing between each plot using the pause function for a specified time in units of seconds. First set up an empty set of axes with equal scaling. Then run it through a for loop and successively plot points. This is a simple animation. Finally, let's look at 2D plots. First, use NumPy MeshGrid to create two arrays X and Y that vary separately in the X and Y directions. First, create 1D arrays along the sides of the grid, and then use MeshGrid. Then compute a function of the two variables. ImShow plots an image of Z. However, this is not plotted with the X and Y axes shown, with X increasing vertically. To plot it that way, type the following. This is a false color map of levels of Z. The color map can be shown with plt.colorbar, and different color maps can be used either in ImShow or with a separate function, or more simply with a function of the same name as the color map. There are many choices. Some of these are other 2D plotting functions are plt.contour. Set equal aspect ratios before. There is also a filled contour map. To overplot the contour lines in black, do the following. There are other functions such as quiver to plot a vector field, polar for a polar plot, scatter for a scatter plot, and hist to plot a histogram. And there are many more.